Hello children, today we are starting a new chapter. Till now you have done lots of additions, subtractions, multiplication and division, isn't it? But most of the times you only used a few numbers. In this chapter, we will be looking at lots of numbers, that is, groups of data or some bunch of information, and we will learn to look at it, analyze and interpret it, and understand what the data is trying to say. And children, remember, don't just sit and watch like a movie. Get a pen and paper so that when you do it yourselves and discover things, you will learn better. Numbers and data are everywhere around us, and we use numbers in many aspects of our daily lives. We use numbers in distances, time, when we go to the market to buy something, and in many games and sports also. And we also use numbers in different studies, experiments and research projects. Let us start and see how to look at this data and understand what it is trying to say. You might have seen such groups of data or numbers and graphs in newspapers, television and internet and many other places. So what type of a graph is this, children? You have made similar things before, isn't it? They are called bar graphs. This graph shows information about the coronavirus cases. Starting from February, it shows the daily cases of COVID-19 in the entire world till the end of August. We will also learn how to read such graphs with huge numbers in this chapter. This infographic shows the amount of internet traffic each person is using on a monthly basis. As you can see, it is grouped according to different regions in the world. You can see the columns named year 2025. You may be wondering, how are they showing 2025, which is in the future? So, what statisticians do is, they look at the trends about current usage patterns, and using that, they make predictions about the future usage. So, a statistician is a person who looks at data, analyzes and interprets it, and comes to some conclusion about it. So, the journey that we are going to take today is in that direction. Here is one more graph, a bar graph. This shows how many hours per week parents spend time helping their kids in different countries. According to the study, Indian parents spend more time than other countries' parents. But children, you may ask, how did they get this information? Because no one came and asked my parents about these things. So, children, you know how big the world population is? So, it will be very difficult for them to contact each and every parent to make this study possible. So, what they do is, say they select some group of people and they use this as the representative of the whole population. So we must be careful when we are looking at these graphs, as these studies may not be completely correct always. Children, do you know what the country's national animal is? Yes, it is tiger. And did you also know that it is one of the most endangered species in the world? And long back, Government of India had launched a project called Project Tiger, which was an initiative towards tiger conservation in the country. Here is an infographic showing how many tigers died in different states of our country and also the causes of their death. And here is a line graph showing how population increased from 1950 till now, and also shows the prediction of future population trends. Children, as of now, the population of the entire world is about 7.8 billion or 780 crores. Here you can see that they have shown how much conducting elections costs each time, and the numbers written are in crores of rupees. One more such graph shows the number of voters in each country in decreasing order. You can see India is at the top. Children, did you know India is the largest democracy in the world. Now that you have seen different types of data and graphs, we will try to create some data on our own. Now I have a task for you. What you have to do is note down how many hours each of your family members is sleeping each day for a week. I hope all of you know how to tell time and calculate the hours and minutes. Make a table like this. After a week, look at the table and see who is sleeping the most and who is sleeping the least. And is each person sleeping for the same time daily or how much it is changing? Look at the table and you can make many more observations. You also try this activity. What you have to do is see how many seconds you take to do 10 jumps. Then rest for a couple of minutes. Then try again and do 30 jumps. Note down the number of seconds. You can do this daily for as many days as you wish. Try at least for a week. Children, don't do this just after eating or drinking something. Children, do you know what Olympics is? So the Olympics games are international sports competitions conducted once in 4 years and thousands of participants from all over the world take part in this. The 100-meter race results of Olympics 2016 is here. Find out who is first, second and third. These are the same results, but it is nicely ordered in ascending order. Now see who is first, second and third. You might have realized that when we sort or order the information that we have, then it is much more easier for us to understand what it is saying. Have you tried running 100 meters before? How much time do you take? A running race was conducted for two different sections of students, and the number of seconds they took was noted. So, which section do you think ran better? In both the sections, the fastest runner took 14 seconds and the slowest runner took 18 seconds. Looks like both the sections performed equally, isn't it? But children, look at the numbers in between. They are not same. So we want some other way to be able to tell which section did better. Children, think how else can we decide which section ran better? Here is another scenario. Two teams were asked to make as many origami models as possible within 10 minutes. Here is how many each team made. Team A of 6 people made 3, 5, 2, 2, 5 and 6, totaling 23. And Team B made 8, 4, 7 and 3, a total of 22. So, which team was faster? What do you think? You may say Team A, but Team A also had more people. But Team B had fewer people and they did lesser models. Team A had more people and they did more models. So now how to decide which team was faster? If both the teams had same number of people, then we could have easily said which team was faster. But now how can we say? Think about it, children. Say we have a can filled with 8 liters of milk and another can having only 3 liters of milk. If this has to be equally distributed in these two vessels, how many liters will each vessel have? This is easy, right? So totally there are 11 liters of milk. So half of it is 5.5 liters. So each vessel can have 5.5 liters. Good. But now we have 3 cans of 7, 6 and 3 liters each. Now if it has to be equally distributed into these 3 vessels, how much should we give to each vessel? In the same way as we did before, we can add all these to get 16 liters. 7 plus 6 plus 3 is 16 liters. And then we can equally divide it into 3 parts. So what is 16 divided by 3? What do you get? It will be 5.33 liters in each vessel. We will look at one more scenario. There were 7 kids and they thought of doing something fun and divided themselves into 2 groups. Group 1 had 4 kids and group 2 had 3 kids. So each group has to decide upon some sweet and bring as many pieces as they can. Then each group will collect all their sweets and give it away to the other group. So they are exchanging. But coincidentally, both groups had decided on the same sweet, Mysore Pak. Group 1 brought 12, 7, 9 and 8 pieces. And group 2 brought 6, 10 and 8 pieces. Then they exchanged. So group 1 gave 36 pieces to group 2. So that is 12 plus 7 plus 9 plus 8, 36 sweets they gave it away to group 2. In the same way, group 2 also collected all their sweets and gave it to group 1. So 6 plus 10 plus 8 is 24. So they gave all those to group 1. Now each group shares among them whatever they have got equally. So how many pieces will each kid in group 1 get? It's straightforward, right? Each will get 6 pieces because there are 24 sweets and there are 4 people in group 1. Similarly, how many pieces does each person in group 2 get? So there are 36 pieces and there are 3 people. So it will be 12 each. But what if they had not exchanged? Then how many pieces each group will get when they share equally among themselves? So group 1 has 36. When they share it among themselves, they'll get 9 each. And group 2 will get 8 each. So most of the times in our daily lives, we don't use the exact values. So we keep making statements like this. Anu plays around 3 hours on weekends. The average temperature in Bangalore around this time of the year is 22 degrees centigrade. Aisha walks about 3 kilometers every day. Meher usually wakes up at 7 am. The average age of students in my class is 12 years. The words underlined here are representative values. So you can also describe your observations of the sleeping hours and the time taken to jump in a similar way. A very common representative of group data is arithmetic mean. Say we have 2 milk cans of 8 liters and 4 liters. So the average quantity of milk in these cans is 6 liters. That is the total quantity divided by the number of vessels, which is 8 plus 4 divided by 2. Mean is also known as average. And arithmetic mean is defined as the sum of all observations divided by the number of observations. Now we have these three containers of 7, 6 and 5 liters. So what is the average quantity? It is nothing but the sum of the quantities in each vessel divided by the number of vessels, which is 7 plus 6 plus 5. 7 plus 6 is 13, 13 plus 5 is 18. 18 divided by 3, which gives 6 liters. So the average here is 6 liters. Coming back to this question, we will look at which team was faster using average. So team A, the total number of models they made is 3 plus 5 plus 2 plus 2 plus 5 plus 6. So this is 5 plus 3 is 8 plus 2 10, 12, 17 and then 23. So they had made 23 models. And so what is the average? The total divided by number of observations. So 23 divided by 6. So what is 23 divided by 6? Is a 18 and 5, 6, 8 is a 48. So the average of team A is 3.83 models. Similarly, we will calculate team B's average. So the total of team B is 8 plus 4 plus 7 plus 3. 8 plus 4 is 12, 12 plus 7 is 19, 19 plus 3 is 22. So their average will be 22 divided by the number of observations, which is 4 observations. So what is 22 divided by 4? So it is 5.5. The team B's average is 5.5 models. So children, looking at these numbers, we can say that team B made more models. That is, they were faster compared to team A people. Coming back to this question, we will look at which section ran better using the average. So first we will calculate section A's average. Section A's average will be the total time taken by all the students divided by the number of students, which is 15.71 seconds. This is the average for section A. We will look at the average of section B in the same way. So the total time taken by students of section B divided by the number of students, which is 16.57 seconds. Now students, who did better? Section B, is it? Just because they have the higher number doesn't mean they did better, right? Because we are looking at who ran better. That means who took lesser time. So section A's average is lesser. So they ran better. You can also calculate the average sleeping hours of yourselves and your family members and the time taken to do 10 jumps and 30 jumps in these tables after a week of observations. Children, you all know what this is. It's a number line, isn't it? So, some children are playing a game using the number line and their starting positions are given like this. They have fixed their places and they have a green ball to place it. The condition to keep the green ball is wherever the ball is kept on the number line, the sum of the distances of the kids standing to the left side from the ball should be the same as the sum of distances of kids standing to the right of the ball. I will show you an example. Say if I keep the green ball on 2, then the distance of students to its left is only 1, as there is only one person standing to the left of the green ball. And similarly, the distances of students on the ball's right side is 1, 3 and 5. So, what is the left hand sum and what is the right hand sum? Are they equal? Left hand sum is 1 and right hand sum is 9, and they are not equal. So, we can't keep the ball at 2. Just by looking, we can easily tell that if we keep the green ball at 4, it will be proper. So, the left hand side, the distances will be 1 and 3. Then the right hand side distances are also 1 and 3. So, the left hand sum is 4 and the right hand sum is also 4. And as both of these are equal, we can place the ball at 4. Now, the kids have changed their positions. They are standing at 0, 2, 5, 6 and 7. Children, now where should we keep the green ball so that, as we saw before, the sum of the distances from the ball to the players on the left is equal to the sum of the distances from the ball to the players on the right. Where should we keep this green ball? You may be thinking that, as we did before, if we keep the ball exactly in the center of the two extremes, that is, in the center of 0 and 7, it may work. Let us try. So, what is the center of 0 and 7? It is 3.5. With the ball at 3.5, let us see what sums we get on the left and right side. So, the left side we have 1.5 and 3.5, and the right side we have 1.5, 2.5 and 3.5. Kids, can you verify once by looking if the distances are correct? So, what are the totals? It will be 5 on the left hand sum and 7.5 will be the right hand sum. Oh, as these are not equal, we won't be able to place the ball at 3.5. So, keeping in the exact center may not work always, isn't it? Now children, looking at the left hand sum and the right hand sum, which side should you think the ball should be moved so that we may get the left hand sum equal to the right hand sum? In which direction should we move the ball? Think, children. We have to move it to the right side, as the right hand sum is more compared to the left hand sum. But by how much? Let us try keeping it at 4. Earlier we had kept it at 3.5. Now we are keeping at 4. Now let us check the left hand and right hand distances. So the left side distances are 2 and 4. The right side distances are 1, 2 and 3. Now let us calculate the sums on the left and right sides. Children, can you try calculating the left sum and the right sum? Yes, they are same. So the left and right side sums are 6 and they are equal. So we can keep the ball at 4. Children, so there are so many positions we can keep the ball at. It will be, so every time it will be very difficult for us to keep the ball at every position and check the left sum and the right sum. We can use a different method to quickly tell the ball's position. So the kids' standing positions are 0, 2, 5, 6 and 7. Children, do you know? We can actually use the arithmetic mean that you have learned just now to know the ball's position. Let us calculate the average for these numbers. You will see what we can get. So the numbers are 0, 2, 5, 6 and 7. Their average will be 0 plus 2 plus 5 plus 6 plus 7 divided by the total number of students, that is 5, which is nothing but 20 divided by 5. And what is 20 divided by 5? It is 4. So we can keep the ball at 4, which we also verified just now by looking at the left hand sum and right hand sum. Say the ball is already kept at 3.5 and we know that it is not the proper place for the ball, as we saw just a couple of minutes ago. But now another kid is joining the game. Where can we ask this kid to stand so that we don't have to change the ball's position? Think, children. We want the left hand sum to be equal to the right hand sum. So where can the new kid stand so that the ball's position at 3.5 satisfies this condition? Yes, if we ask the new kid to stand at 1, then the ball's position at 3.5 need not change. Children, can you verify once? See what the left hand sums are and what the right hand sums are. So the left hand sums are 1.5, 2.5 and 3.5. And the right hand sums are also 1.5, 2.5 and 3.5. So if you add up all these things, we will get 7.5 on the left sum and also the right sum. And as you can see, both these are equal. So the ball at 3.5 can stay there only if the kid stands at 1. I will show you a joke related to what we have learned today. Hope you understood. Children, now is the time for a puzzle. An interesting puzzle using averages. So here is an empty 3 by 3 grid. I want you to fill the grid with any numbers, but there is a condition. The number in the middle of each line, that is horizontally, vertically and also diagonally, should be the average or mean of the two numbers on either of its sides. There are multiple ways to fill this grid. Try how many can you find out. So children, in this class we have learnt what mean is and how it can be used in different scenarios to understand what is happening. Do try out the mean grid that I gave you, and we will meet in the next class and I will show you some possible ways to solve the mean grid and we will learn some more things. Bye.